Hello friends, welcome back to our channel. So in today's session we'll see a few more problems on combinations. So in our previous sessions we have seen the basic problems on combinations and permutations, and in our previous session we have discussed about the circular permutations and the permutations with repetitions and constraints. So in today's session we'll go with the combinations, the two cases, the combinations with constraints and combinations on identical objects, distributing of identical objects. So let's start the session. So our topic today is combinations. So we'll recall the basic problem of combination, so which is selecting R objects from n objects is represented as NCR. So NCR is equal to n factorial by n minus r factorial into r factorial. So this is a basic formula for any combinations. Okay, now the second category. So combinations, constraints also will be using the same thing, but here distributing identical objects. Okay, n identical objects to R either persons or boxes is represented as n plus r minus 1 c r minus 1. So just remember these two formulas. The first one is a basic formula, selecting or choosing R objects from n objects is NCR, and this is distributing n identical objects to R persons. For example, distributing some 5 chocolates to 4 kids. So that will be represented with n plus r minus 1 c r minus 1, and we can apply the same formula for this one. Okay, yes. So now we'll see the problems related to combinations with constraints. So there will be some constraints. So that means, so just selecting R objects from n objects with a small constraints. These kind of problems, and also distributing objects. So we'll see the problems on these two related concepts, right? So let us see a few examples so that you can understand what exactly mean. So let us take this example. So find the number of committees of 5 that can be selected from 7 men and 5 women. So that implies, so here there are total 12 members. So among that 5 are men and 7 are men and 5 are women. Among those 12 we have to select 5 members committee. So how many ways we can select a 5 members among 7 men and 5 women? This is a simple combination. There is no constraint. Okay, so this can be solved as, so n is equal to 12, which is 7 plus 5, right? And R, we need to select 5 committees. Committee with the 5 members. So this can be represented as 12C5. 12C5. So I am not solving that. So just keep aside, right? Now, there is one more question related to the same thing. This is a constraint. See, this is a constraint. So we need to form a 5 committee from 7 men and 5 women such that every committee consists of at least one man and one woman. So this is a constraint. So now we have to solve it. So how we can solve it? So the committee which we are forming with a 5 should contain at least one man and one woman, at least, right? So first let us found 5 are committee with 5 men and committee with 5 women. So committee with all 5 men, that will be, how many men are there? 7 men are there. So 7C5. So from 7 men we are selecting 5. That means all are men. All are men. And the same thing, committee with all 5 women. So there are 5 women. So directly we are selecting all the 5 as a committee. So 5C5. Okay, hope you understood. The first case is forming a committee with all 5 men, no women. And the second case, committee forming with all women, no men. Now we can subtract these things from the 5 among 12, we will get the result. Okay, so total among all the 12 persons forming the 5 committee is 12C5. So 12C5, from this we can minus 7C5 minus 5C5. So this will be the result where we can form a 5 committees of 5 where at least one man and one woman, because we are taking the complete 5 among all the 12. From that we are subtracting forming of committee with all men and forming of committee with all women, so that we'll get at least one man and one woman, right? So you can apply the formula. So 12 factorial by 12 minus 5 factorial into 5 factorial. Similarly, 7 factorial by 7 minus 5 factorial into 5 factorial. Similarly, 5 factorial by 5 minus 5 factorial and 5 factorial. So you can get the result, so that you can subtract from total number, you'll get the remaining thing. So I'm not solving the problem, you can do that. Okay, so simple multiplication, so that you can do, right? Yes. So now we'll go with a one more kind of problem, the same kind of problem, one more, right? So let us take one more example. So here, assume a question paper, QP. I am writing in a shortcut. QP means a question paper. A question paper contains 2 parts, A and B, and each part contains 4 questions. So there are 2 parts, A, B. So I'll write here. Part A, 4 questions, and part B, again 4 questions. Now, how many ways a student can answer 5 questions? For example, if the question ends here, what we have to do? So total how many questions are there? Total 8 questions are there in the question paper. Among that 8 questions, we have to select the 5 questions. So simply we can write 8C5. Okay, among 8 questions, we are selecting only 5 questions. So 8C5. But here we are having one more constraint here by selecting at least 2 questions from each part. So student have to write 5 questions, but among that 5 questions, he have to select at least 2 questions from each part. So here we have to solve 2 things. Case 1, so selecting 3 questions from part A and 2 questions from part B. And similarly, case 2, 2 questions from part A and 3 questions from part B. Okay, so total a student have to select 5 questions. Among that 5 questions, at least 2 questions to be selected from each part. So 2 questions. So student can write 3 questions from part A and 2 questions from part B. Similarly, student can also write 2 questions from part A and 3 questions from part B. So this is represented as each part we are having 4 questions. So 4C3 and this is 4C2. Okay, 2 questions from part B, 4C2. And this is 4C2 and this is 4C3. Okay, so student have to answer both the parts, right? Part A and part B. So just remember, student have to answer both the things, part A and part B. So what we have to do? 4C3 into 4C2. Here 4C2 into 4C3. So you can solve it. So I'll write here 4 factorial by 4 minus 3 factorial into 3 factorial. So 4C3. So which becomes 4 into 3 factorial by what happens here? 1 into 3 factorial, which becomes 4. So this becomes 4 into 4C2. So 4 factorial by 4 minus 2 factorial into 2 factorial. So what happens? 4 factorial by 2 factorial into 2 factorial. So which becomes 4, right? So 4 into 3 factorial by 4, which becomes 3 factorial, which is nothing but 6. So this will be 6. And similarly, this becomes 6 and this becomes 4. So how many ways here? 4, 6, 24 ways a student can select 3 questions from part A and 2 questions from part B. And similarly here also 24 ways, okay, by selecting 2 questions from part A and 3 questions from part B. So student can having a choice of writing, selecting the 5 questions in either of these 2 cases. So student can select this case or this case, or, okay, remember, or, right? So here student have to attempt 3 questions and 2 questions from part B, and so that's why we have given multiplication. Compulsory student have to answer these 2 parts. So here also we have given star, that means multiplication. But here the student can select either case 1 or either case 2 or case 2 or. So that implies the result will be case 1 plus case 2. So here also we should write it as 24 plus 24, which becomes 48 ways a student can select 5 questions from a question paper by selecting at least 2 questions from part A and 2 questions from part B. So hope you understood, right? In this case, student have to select both the parts, so multiplication, and here the student can select in either case. So we are using plus, so total 48 ways. So this is how we have to solve the combination problems with the constraints, right? Yes. So hope you understood this one, and now we'll move on with the second category, that is distributing of identical objects. Okay, so let's see a few problems on that. So now we'll see these 2 problems. See how many ways we can place 10 chocolates among 6 boxes. So this is similar to our distribution. So there are 6 boxes, and we need to place the 10 chocolates among these 6 boxes. So in that we have to use a formula n plus r minus 1 cr minus 1. So which gives n here means 10. So 10 plus 6 minus 1 c 6 minus 1, which becomes, so 16 minus 1 15 c 5. So I'm not solving the problem completely, so you can solve it because you know the formula of NCR, so you can apply and you can find out the final answer. So 15C5. So in these kind of problems can be solved by the formula this one, n plus r minus 1 c r minus 1. So distributing of n objects among r persons or boxes, whatever it may be. Okay, yes. Now the second thing, how many ways we can distribute 7 apples and 6 oranges among 4 children? So here what are the identicals? So first we need to find the identicals. So what are the identicals? Children are identicals? No, all the children are distinct, different children. What are the identicals? Apples are identicals, 7 apples, and oranges are identicals, 6 oranges. So for distributing apples, distributing 7 apples among 4 children, that will be how much? 7 plus 4 minus 1 C4 minus 1, which becomes 7 plus 4, 11 minus 1, 10 C3. Similarly, distributing how many oranges? 6 oranges. Distributing 6 oranges among 4 children. So what is the thing? Same formula, 6 plus 4 minus 1 C4 minus 1. So that means 10 minus 1, it's 9 C3. Okay, so the two cases, the first one distributing of 7 apples among 4 children, so which is 10 C3 ways, and distributing 6 oranges among 4 children, which is 9 C3 ways. Okay, now what is the question? How many ways we can distribute 7 apples and 6 oranges among 4 children? So both the apples and oranges should be distributed to the children, not the single one, right? So the final result will be 10C3 distribution of apples into 9C3 distribution of oranges. So these many ways we can distribute 7 apples and 6 oranges to the 4 children. So we have to read the question carefully and we have to apply either, we have to decide whether we have to apply the addition or multiplication. So here both the fruits have to be distributed, so we have to perform into. If the question is like either, then we will go with the addition. Hope you understood these kind of problems. Now we'll solve a few more problems in this kind of situation. Now let us see one more question. How many ways we can distribute 12 pencils to the 5 children? So here we need to distribute pencils to the children. So what are the identicals? Pencils are the identicals and children are distinct. So the constraint is every child gets at least one pencil. So every child should have at least one pencil. So how many children are there? So total number of children, 5. Total number of pencils to be distributed, 12. And constraint, every child should have one pencil, right? Every child should have one pencil. So what we can do? So initially distribute one pencil to every child. Distribute one pencil to every child. So remaining pencils for distribution. So after distributing one pencil to every child, how many pencils are remaining for distribution? So total 12 pencils. Among 12 we have distributed 5, so which are 7. Hope you understood this, how we got a 7, right? So here the constraint is every child should have one pencil. So what we are doing is, initially we are distributing one pencil to every child. We are distributing one pencil to every child. So after distributing one pencil to every child, how many pencils are remaining for distribution? So out of 12 we have distributed 5, so we are having only 7. Now you can use the formula. We need to distribute. So here we have to distribute 7 pencils to 5 children. We need to distribute 7 pencils to 5 children. What is that? 7 plus 5 minus 1 C 5 minus 1. So which becomes 12 minus 1 11 C 4. So this many ways we can distribute 12 pencils to 5 children, so that every child gets at least one pencil. So based upon the constraint we have to solve the problem. Okay, based upon the constraint we have to proceed with the solution. So these many ways we can distribute the pencils to the children, right? So hope you understood these concepts. So in this session we have seen a basic combination, that means how can we select R objects from N objects, and similarly how can we distribute N identical objects to R distinct persons or boxes. So that also we have seen, and also we have seen a combinations with constraints. How can we solve the combination problems? Those are having some constraints, right? So let's stop here, and hope you enjoyed the session. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.